Welcome newbie makers and aspiring engineers. I'm Professor John Gallagher, and in this short lesson I'll show you how you can use the rails on a breadboard to simplify your wiring. We'll also learn to follow the path of each connection to make sure things are hooked up properly. I'll do this using a Raspberry Pi Pico board, but the concepts can apply to other boards as well. Now, as mentioned in a prior lesson, when you hold a breadboard this way, the vertical columns on either side of the center gap, which is called the ravine, are connected. The ravine separates them, so the vertical connections don't cross this center line. These columns, or vertical connections, are sometimes called terminal strips. Now, each of the two horizontal rows at the top and the bottom are also connected, but horizontally. These are called the rails, or sometimes the power rails. Now, because these horizontal rails are connected, that means you can use them to share ground and power. Only make a single connection from each rail to a power or ground pin. Now, the reason the connections work this way is because if you were to open up a breadboard, this is what you'd see inside. These vertical metal bands connect the columns in the center, those are your terminal strips, and the horizontal bands at the top and bottom connect the rails. Now, using the rails requires more wiring, but it can keep things neater because you can use smaller, more direct wires to the rails, and it can eliminate the breadboard spaghetti wiring that might otherwise obscure access to pins on the board. Let's see some examples. This is an example of using a NeoPixel strip connecting directly to power and ground pins on a board versus connecting using the rails. This NeoPixel strip uses the bottom rail for ground, and that rail is also attached to this pin, which is one of the Pico's ground pins. And the power wire goes to this rail, which is also connected to the V-bus wire, this one on the Pico. You know your wiring is correct if you can trace your connection from component to board. For example, if I start at this ground on the NeoPixel strip, I head to the rail, then move along the rail horizontally until I reach this ground wire, which connects me to one of the ground pins on the Pico. Same thing for the power wire on the NeoPixel. It takes me to this power rail, I run along the rail until I get to this wire, which takes me to the V-bus power on the Pico. By the way, if you wanted to double check which pins are which on the Pico, you can open a browser and visit pico.pinout.xyz for a handy interactive pinout diagram that you can use for either Pico or Pico W boards. The pins on those boards are the same. Here are some more examples. Here we've added a button. It only needs signal and ground, no power, but I've connected ground on the button to the top ground rail, and I've connected that rail to this ground pin here. This lets you use shorter wires, and it should make it easier to get to the other pins on the breadboard. Now, here's a more complex example of using the rails. We've got 5 components hooked up here: a servo, a NeoPixel strip, a potentiometer knob, a button, and a STEMMA-QT connection for I2C peripherals. Now, in this setup, I've got the 2 power rails connected to 2 different power sources. This bottom rail is connected to V-bus power, since the servo motor and the NeoPixel can handle the greater power of the V-bus pin. But up top, I've wired this power rail to the lower power 3.3V out pin on the Pico. That's because the potentiometer and the STEMMA-QT port only want 3.3V power. Now, if you were to wire things up directly without using the power and ground rails, then count up the wires, you'd see that using the rails requires an additional wire for each rail connected to the board. But even though we have more wires this way, we limit wiring spaghetti because we can wire directly to the rails, and we don't have to loop some of these wires over the board. Wiring over the board can make it more difficult to get at the signal pins. Wiring with the rails also allows me to share power without having to bunch wires directly next to each other in the vertical columns for power. And if I needed more than 2 power connections on either of these power connections, I'd run out of pinholes if I tried to wire them directly to the pins, but I've got no problem adding more than 2 pins along the power rails. So you can use either of these methods, direct wiring or using these horizontal rails. And hopefully now you also know how to trace out connections to make sure wiring is properly hooked up. Now go make something awesome.